Yeah, sorry about that. I just had to make sure that it is recording. Yeah, okay. So, okay, so what I'm planning to do for this session, for at least my sessions, is mouse pointer is pen. Okay, so problems on network parameters. I'm going to start with your CAT questions. So we had one question. It was a confusing question in your CAT, which was about network parameters. It was about bandwidth and delay sensitivity. And after that, I'm going to move on to some theoretical based questions. So my slot, I mean my PPT, my the UTS sessions that I was taking, we were having quizzes after every module, and so these quizzes usually had like MCQ questions. So we'll discuss some of those questions also. They were mostly theoretical questions. There were a few problems, but we'll see. And after that, the plan is to solve exercise questions. So let's see how much we can finish because exercise questions do take time. But if we're able to do it, it'll be good. So that's our overall plan. Uh, okay, good. 70 people have joined. Okay, let's begin. So this is when we discussed previous. So previously when we were doing sessions separately. So I'm gonna. So let's start a new section today. And so what I do is I share. You're gonna get. Yeah, what you're gonna get is you're gonna get the recording. You're gonna get this material. You're going to get the questions that I did and how I solved it. I'll try to share anything that I can share. Anything more that you want, you can let me know, and I'll try to share that also. So here is UTA session, one, or I should say common UTA session. Okay. And if you this question might seem familiar to you because this is the question that came for your cat. It's a question that first question today. Okay. So I thought I would show you a question and give you some time to solve it, but this question is something that you've already seen, so let's just move on. For each of the following operations on remote file server, so that's something remote file server, discuss whether they are more likely to be delay sensitive or bandwidth sensitive. So I know if you were in my previous sessions, you would know that we already solved this, but let's quickly go through this again. The first thing that we see from here is remote file server. So what is a remote file server? You have a host, you have your host, so let's say your PC in your network, and you have your file stored somewhere else. So let's say there's some uh, server like some cloud somewhere, and you need data transferred from that server, and you can also transfer to that server. So you have server and you have host. Yeah. And the question is asked that we are asked is they discuss whether they're more likely to be delay sensitive or bandwidth sensitive. What does that mean? What is delay? When is it delay? And when is it bandwidth? Simple rule. I think this should be visible. Let me please. Okay. Delay and bandwidth. Delay is when you is all about speed, how fast, how fast you want something to transfer. Bandwidth is all about capacity. So how much the network needs to transfer, right? Transfer, right? So anyway, if you're solving this question anyway, you need to first think is Are you looking to increase speed, or are you looking to get as much capacity as you want? So now let's go through the options on there. The first one is open a file. So what happens when you're opening a file from a remote file system? Let's say you know where the file is. You have your directory. Let me just represent it like this. You have your directory, um, and you're going to pass a command saying whatever open, and then your directory will be there. So this assumes that you already know your directory. All that you want to do is open it. Now, one question you need to ask yourself is, if you're opening, is there files being transferred? Is there capacity that's being transferred from the server to the host? And the answer is actually no, because when you open a file, all you're doing is you're sending a command. That command needs to travel to the other part of the server, and then it is open still on the server. And so you don't need um, a heavy capacity network. What you do need is speed. You need this message to transfer all through to the server, and you need to receive, you need to be able to view whatever it is. So that's all that you need. So to simply put, this is delay sensitive. Okay. Reading the contents of the file. Reading. That means once it is open on the file server, you want to be able to read the contents. And maybe you want to run some script on the computer or on your host. At that time, what would be needed? You would need data, right? You would need data to be transferred, right? Data. And when you need data, it is all about capacity, right? So how much the network needs to transfer. So reading the contents of a file, that is bandwidth sensitive. Now you would ask yourself, like, why not also delay sensitive? Why not also? Because speed may be important. The answer for that is, well, the main goal here was to read the contents. Even if it takes long, just for your script to run, the main thing is getting the contents, however long it takes. And that involves transferring it from the server to the host. That anyway is my logic behind this question. Okay, next, listing the contents of the directory. This is an interesting one, because you have data, because you're going to list. So list is going to be some list of data. You need that to transfer and come to your host, right? And you also need to open file directory over here. So it's almost like a combination of opening and reading. Also, wait, so this was bad. That itself should tell you that this is both delay and bandwidth. In a previous session I had, there was even I had this doubt. So is it possible for something to be both delay and bandwidth sensitive? And this is the best example of this, because you're opening a file and you're reading a file. You're by that happens when you're listing the contents in the directory. What about displaying the attributes? So if you know how you list the contents of a directory in case in Linux, what you do is you put a command and you would get all the file names, right? And you can add another parameter to that, and you would get all the permissions. So who did it, who created it, who has permission to edit it, all these things will also come. So in a way, these C and D, C and C and D are actually almost the same, because listing the contents and displaying the attributes are very similar, very correlated to each other. They resemble each other. And so this is also going to be, for the same reasons of C, delay and bandwidth. And I know, I think we're going a little, maybe a bit too slow, but once you share the recording, did somebody say something? No? Okay. Okay. Yeah. So if we are going a little slow in this, I mean, once if you do get the recording, you'll be able to play at 2x, 3x speed, finish it faster. But yeah, so for the sake, at least for the recording, we will go a little slower. Okay, downloading the file. Now this is something where you're transferring data from one server to the host. You are also you also want it to download fast. The thing is, even if the file does not download fast, what your major concern is that packets are not lost. So how do I? So if you have to you're sending from one place to another, so it's from the host to the server. The major concern for downloading is that the packets are not lost. And even if this takes time, even if there's delay, like we would all prefer a download to complete rather than uh, give an incorrect packet, get a wrong software, or get a wrong download. So this is primarily, like mainly, binary sensitive. You could also argue and put delay sensitive. It's not wrong, but then you'll have to justify what kind of system you're using, what are your priorities in the system, who, what kind of service that you're giving. If you can justify that, then definitely delay sensitive will also be included in this answer. But otherwise, mainly it's a bandwidth sensitive thing. So let me put it in. So you can say delay sensitive, but you have to justify that you're using it for a very specific application. But mostly it's bandwidth. Okay, that was our cat one question. I think the other questions in our cat, I think this should still be useful. Yeah, the other questions, you had error correction, another error correction. Okay, so those will be handled by another UTA, not me. And in summer session, you should still get the recording of that. Okay, so that was the first. That's how we start. Okay, what do we do next? Theory. Yeah, we can do theory. Okay, so just give me a minute. I will get the questions that I prepared. So we have question two. Yeah. Mm, just give me a minute for this loads up. So what we need to do is what our aim was to create quiz questions. So I have these quiz questions that we were supposed to make a quiz, but I don't know whether we will because now that we have combined. But in case we do make quiz, you here are the answers, right? So yeah. Hmm. So this is copied directly from the quiz that we had made before. Jitter, jitter. Jitter refers to the variation in what? Variation accuracy of the packets, arrival of the packets, connection tear down, and connection setup. Now, there's so you have to remember. So it's the answer is some just gonna put it here. It's arrival of packets. What jitter does, if you've ever played games, or you will have a jitter score. And what this is is it's almost similar to your ping, but it's not exactly a ping. It's how fast the latency between two latency bit of the packets between two sources. That's jitter. And so if you had a network coming from the messages going from one to the other, how much variation it takes. Let's say, so you have from A and you have B, how much variation there is between when the time packet sends from A to B and something from B to A, that's jitter, right? Like let's say, take for example, you had packet 8, so A to B took 5, and then it took 6, and then it took 5 again, then it took what, 5.5. This is something with low jitter, right? Because there's not much variation. But if you had something like 5, let's 7, 5, 0, so nothing arrived, and then 10, this is very high jitter, this is high, and this is low. That's basically jitter. And so you would immediately know that it's arrival packets. It's not accuracy. Packets can arrive fast but wrong, but jitter does not take care of that. It's not connection tear down. Jitter is a metric. There are no metrics for how fast a connection gets built. It's not connection setup also. So those two options are gone. It's actually the okay. So I think we don't have to spend too much time. I can put in a few more questions. Hmm. Put this. Otherwise, I'll create a new. So cures the oh, there is one, and here is another. Oh, I did not. Okay, here's another. So what I'm trying to do in this session is only do network parameter things. Packet switching will do in the packet switching. Yeah, packet switching will do in the next 2 hour lecture. Okay, this question. When a signal travels through a medium, it loses energy in a phenomenon known as distortion, attenuation, amplification, modulation. You should know immediately that when you're losing energy, it's definitely not amplification, because that's amplification. When you amplify something, you make it bigger. It's not distortion. So we'll talk about distortion. It's not modulating. So you can modulate something from modulate since you have a signal, you need to modulate it from into another signal. You can do this without losing energy, right? So that's why it's not modulation. The only thing is also distortion and attenuation. Distortion again, you could distort a signal. So for example, you had this, let's say this signal, and then you made it lost energy and whatever it became. So this is actually lost amplitude. So lost energy. That is a form of distortion. Yeah. Oh.
Timothy Charles, this is Sublakshmi.
Oh yeah. Yes, ma'am. Good evening.
Yeah, good evening. So actually, can I know from which references or which sources these questions are actually being given?
Uh, so right now these questions on my screen, these are from, so I made these questions textbook, uh, from the textbook, the portions that we had.
Okay.
The previous,
Whether all these questions are actually there, is it?
you mean, I'm sorry, ma'am, can you, I didn't understand.
In the textbook, you mean to say that all the questions are there, is it?
No, ma'am. So this question, I wrote it like from the passage. It's not there on the textbook. but the answer is there. Like it'll in the textbook, it'll be written this full sentence.
Okay,
That's
okay.
this
What
one.
is this?
The first
Yes.
one.
So what I say is that you can go sequentially from the questions. Okay, so rather than this theoretical concepts, no, students are struggling basically for the problems to be solved. So that's why in the schedule also we have given that problem solving. Okay. So
Mm-hmm.
maybe formula and problem solving in that way you may proceed. Okay. Possibly,
Oh,
from the textbook, most of the book back questions, uh, book back questions of the textbooks, we can actually take it. Otherwise, from the book back questions, you can write some little modified questions.
okay. Okay, ma'am.
I hope you
With
might have prepared in the same way. But anyway, just a reminder.
oh yeah,
I'm not
yeah,
very
yes, ma'am.
clear for the previous session, but just some instructions.
Okay, okay, ma'am. Yeah,
Okay, so you
yes,
can
yes, ma'am.
continue. Yeah, you can continue. Not an issue. Things are going on well.
Oh, okay. Thank you, ma'am. Yeah, I'll try to focus on more formulas. I think more
Yeah,
of
more
formulas
form.
and less. Yeah.
And actually, for those students who are attending also, if you're having any query or if you want some of your problems to be solved, then you can just share them to this person so that he can address the same in the next sessions. Maybe some of your CAT questions or some of the questions, if you share it to him now, then he will solve it in the next session. Okay. So you can also teach it from the textbook and request the students also to have free interaction with you so that this sessions would be fruitful. Okay. So all the best. You can
Yes, ma'am.
continue for the judge.
Yeah, yes, ma'am. Okay, thank you. Um, yeah, we were doing this question. So this is actually just theory only. So after this, we can move towards some more numerical based questions. We can solve that. Just quickly, we were talking about losing energy and distortion. A signal can lose energy and be distorted, but as I was showing, so if you have a signal and it completely is distorted into something else, this is also distortion, but we don't. It doesn't tell us anything about the energy. So that's why the answer is only attenuation. So we eliminated everything else. And if you knew attenuation, immediately you should know that something weakening. That's how energy. Um, Compensate for the next question. This is also a direct theory question. Uh, Compensating for energy loss in a signal, what is utilized? Antennas, amplifiers, transmitters, and receivers. So if you have energy loss, you need something that would make up for that energy loss. It will give more energy to the signal. So whatever is the opposite of something that's losing. It's not antennas and transmitters, because these are devices that allow signals to travel from one node to another. They do not do anything about signals. They do not do anything about the energy of the signals. The energy of the signals is lost as the signal continues to propagate. Again, receivers is also not, because for the same reason. And amplifiers, as the name suggests, amplifying the signal. So if you read network models and network architectures, if you had nodes between two faraway places, you would have an amplifier in the middle. So you'd send a signal to the amplifier. You would lose some amount of energy. The amplifier would amplify the signal, and then you'd be able to pass it on to the next node. Right? Okay, so that was these questions. Just give me a minute. I'll copy another question. This is a little bit more numerical based question, unlike the theory we had seen before. This is from textbook. This is from the back end. So at the end of your chapter, you have some exercise questions. This is directly taken from that, and it's not a typical question. So we are asked what is the transmission time of a packet sent by a station if the length of the packet is 1,000,000 bytes, 1,000,000 bytes, and bandwidth of the channel is 200 kbps. So you have a packet. Yeah, you have a packet. The total length is what is given. So you have, let's say, so we are given as 1 minute. So I'm just going to write that as 1. You need to send this packet from one station to another, and the bandwidth is given. So what is the bandwidth? Bandwidth is the capacity of the network between these two nodes. So let's say, yeah, this is A and B. You have the network between this. The capacity of the network, the bandwidth, is given as 200 kbps. So let me write 200 kbps. Okay, now we are asked, what is the transmission time? So it should be quite clear now. So you have this total distance, sorry, not total distance. You have this total speed. This is a speed. So 200 kilobytes per second. And you have this total length that needs to transfer. So then it becomes a simple time is equal to oh, okay, yeah, so I had unfortunately allowed annotation. Okay. Yes, it's disabled. Okay. So we were talking about time. So we know time is length by speed, or as you would say, we'll say distance by speed, right? Because we know speed is distance by time. So that's what's going to give us the clue to solving this. So in terms of in network terms, so the transmission time, that's going to be equal to the distance. Now what's the distance here? Distance is this is what needs to be transferred. This packet needs to travel this network and reach B. So it's going to be the length of the packet. So length of the packet, and then you have the speed. And the speed here you're given the network has a bandwidth of 200 kbps. That means every second, in 1 second, you're transferring 200 kilobytes. Right? So length of the packet divided by the bandwidth. That is all. That is all that you need to do. So let's find out what that is. Transmission time is equal to the bandwidth. So now the bandwidth is given here as 200 kbps. So that's 200 kbps. K is 1,000. So you're gonna add 3 more zeros. So that's number of bytes divided by 1 million. So 1 million is 100,000, 2, 3, 6 zeros. That is what we are given. Right? So we're given the length of the packet and we put, oh no, I've done, I've done it the other way, sorry. So it's 1 million bytes, the length of the packet, divided by 2 K. And also one thing you have to remember is this is 1 million bytes, so that's capital B. And this is B, small b. Small b is bits. And 8 bits, 1 byte. And so this bottom term will need to be multiplied by 8 to get number of, sorry, this would be have to be divided by 8 to get number of bits. Or simply you could multiply the numerator with 8. That's simple. So the final thing would be 8 million divided by 200k. And all now what is left is that you need to just solve this. So 5 zeros, you're getting 4. I think 4, no, 1 more 0. So 40. 40 seconds, right? So the unit of time which you're using is seconds. Seconds. That's it. That's your answer. So what same? So your asked transmission time. We've given how much needs to be transferred. The length of the packet here is 1 million bytes, and you're given the bandwidth between these two nodes, which is the can be said as how fast something can go. So we're given 200 kilobytes per second. So in 1 second you have that many kilobits. Small b, yeah. Transmission was length divided by bandwidth. We took the length, converted it into bits, from bytes to bits, divided it by the bandwidth of the channel, and we're able to get our answer. So that's our final answer. Okay. Let me take something else. Here is another question. So we are given, so we're asked, so what is the length of a bit? So length of a bit, so very similar to the previous question. Length of a bit was what we had seen was the distance that needed to be traveled from A to B. What is the length of the bit in a channel with a propagation speed? This is meters per second. I mean, sorry. We're given the propagation speed. I think there's some. Yeah. Oh, sorry. Yeah. So we're given the speed, and we're asked what is the length of the bit. This is meter per second. Yes. So you're given how much. So how fast the bits can travel from one node to another in the network, and you're asked what is if the bandwidth was 1 Mbps, 10 Mbps, 100. So this is millibits per second. So it's very similar to what we had done before. So again, you will do the distance is going to be the speed divided by time. Oh no, speed into time. Yeah. No. So wait. Speed into time. Yeah, okay. So distance, speed into time. What is the distance? What is the speed? What is the time? Speed is given directly here. So that's out. That's this. Right? Distance is what we need to find out. That's the unknown. Time is what we don't have. Right? We are given bandwidth instead of time. So how from the bandwidth, how do we convert it to time? So it's actually simple. So in 1 second, how many bits travel? 1 million, right? And so the time that it would take to travel a single bit. So the question is about a single bit. So if 1 million, so let me write it. If 1 million takes 1 second, how much does one take? So this is a easy way to find out. It's actually 1 by 1 million. So the time is actually 1 by 1m. Right. So now you have everything that you need to solve the problem. So the length of the bit will be the propagation speed, propagation, propagation. Okay, propagation speed into 1 divided by how many, whatever is the bandwidth. So bandwidth. That's all that you need to do. And this you can just apply to all of them, and you can find out. So if you want, we could work this out. A would be propagation speed 2x 10 raised to 8, 10 raised to 8 times 1 divided by 10 to the power 6. So if you would solve this, you would get the answer. Second one would be 2 into 10 to the power 8 into 1, 10 mbps. So you have 10 to the power 7, right? So into 10. So 10 raised to the power 6 into 10. And the last one, 10 raised to the power 8, 1 by 10 to the power 8. That's all. That's the answers. So I mean, you would have to simplify this, and it's actually easy to simplify. So what would happen is you would put so this 10 to the power 10 to the power 6, you would cancel it with a 10 to the power 8, you would get 200, right? I think, yeah. So this is, oh, it's going to be 200. Yeah, 200. This would be 20. This would be just 2. 2 what? So our unit here, our unit here was meter per second. So it's going to be 200 meters. 20 meters, 2 meters. This is just to show that this, if we had this kind of propagation speed, look at the size of the packet. 200 meter for just one packet, right? That's why speed matters so much. So these are bandwidths that are regularly seen, but based on how much the propagation speed, see how big the packet sizes become. Okay, that was this question. That's your answers. Okay. Number 7. Yes, number 7. So give me a minute. I will be back in a minute. Yeah. Okay, this is another related exercise. We are given, we're asked what is the bit rate for a signal. So bit rate is asked. And we are given signal is lasts. So one bit is 1 millisecond. Yeah. Um, 1 bit lasts 2 milliseconds. Once 10 bits last 20 microseconds. So how would we solve this? Okay. Bit rate. What does bit rate mean? Your bit rate is, so what is any rate? Your rate, or like it's similar to speed, right? So again, it's going to be distance by time. That's all you need actually. So bit rate is so you have distance. So how big the bit is. So length. So length divided by time, which is just time. Length is basically how many bits, right? Because how many bits are you doing in how much time? So again, then bit rate becomes number of bits divided by time. That's all. That's the only formula that you need to know. Last one. Bit rate is number of bits by time. That's all. That's all that you need to calculate. So let's quickly solve this. This is an easy question. For A part, bit rate is equal to, so how many bits? 1 bit? Everywhere it's 1 bit. Except the third, except the last part. Yeah. So you have how many bits? 1 bit divided by how much time? 0.001. And it's given here, it's coming to 1000. So 1000 what? What is the rate? What is the unit of bit rate? Number of bits, that's in unit B. Time, everything is given in second. So the unit is going to be bits per second. Or textbook says BPS. So BPS. Or you could also write this as 1K BPS. Bits per second. KB, 1K BPS. Actually asking which lasts 1 bit lasts 2. So bit rate is equal to 1 divided by 2 milliseconds. So let's write it as 0 to 500. 500 what? Bits per second. Or this we could write it as 0.5 kbps. Okay, bit rate equal to 1 divided by a signal which lasts 10 bits. 10 bits last 20 microseconds. So you have 10 instead of 1, 10 bits and 20 microseconds. So you need to put 6 zeros. Is, yeah, 500,000 bits per second. So this can be rewritten as 500 kbps. That is your answer. And you'll notice now that bit rate is actually the same units that we use for another quantity, bandwidth. Right. So these are actually bit rate and bandwidth use the same units. And that's all. This is your answer. You're asked to calculate the bit rate and you're given how many bits and you're given the time. And you know number of bits that can correspond to how much data, the length. total distance, and then the time is directly in the question. You're given 1 millisecond, 2 millisecond, 20 microsecond. You just need to put it into the formula, and that's it. Solve it, simplify it into 1 kbps, whatever. So even like mbps or whatever is suitable to simplify it, and then you get your final bit rate. That is all for this question. Okay. Let's see what we can do next. Oh, this is our eighth question. What is the bit rate for this? So this is a question which has a diagram. Let's okay. So we are asked again calculate bit rate. So it's very similar to the one that we already did. So remember how we did this. What is the bit rate? And we're given a signal, and we're not given any values, but we're given this diagram. We would be able to solve this problem if we're able to get those values from this diagram. It's actually very easy. Time is clearly mentioned. So we make it a little bigger. Yeah, time is right there. 16 seconds. 16. So time equal to 16 plus 15 x and 2 minus 9. Okay. Now what else do we need on the previous question we saw? We need number of bits. And one mistake that not everyone, but some it's a probable mistake would be to say, so you have a signal, you have 1, 2, 3, 4, and then say that there are 4 bits. That's actually wrong. Yeah, that's actually wrong. This is actually representing what the signal represents is the values of the bits. So this is a 1, right? This is nothing. So it doesn't mean that there was no bit here. It means that it corresponds to value 0, right? This is again 1, again 0, 0, 0, and then again 1. So how many bits do we have in total? 2, 4, 6, 8 bits, not 4. So that was how we can find number of bits. 8 bits, right? Because each duration that's shown on this diagram, that represents the value of 1 bit. So as you can see, let's say probably we don't know, but let's assume this some x nanoseconds. In that x nanoseconds, this 1 bit output was shown. And bits, they're either 1 or 0, right? 1 or 0. And that is why we do this. That is how we're able to get this signal. So very quickly now the problem is actually solved. So we have time and we have number of bits. Now nothing, we don't need to do anything. Bit rate. Let me just copy same thing that we had here. Bit rate, the speed, distance by time, which is actually the length of the bit by time, which is the number of bits by time. So simply you can write bit rate equal to 8 bits divided by 16 x 10 to x 9. It's not 0, so it would be 0.5 into 10 to 9. right? Because 8 divided by 16 is 0.5, and then you would move this up, right? So okay. So when we expand it, we get this. This is actually 500 million bits. Right? So we can rewrite this as 500 million. Million what? So bit rate. So bit rate, like we saw before, we're looking at bits in 1 second. So this is going to be Mbps, bits per second. That's what. This is your answer. 500 Mbps. So whenever you're given bitrate questions, maybe you'll be given values like this, where they give how many bits in time, or maybe you'll get uh, diagrams like this. And whatever you're given, you need to be able to find out number of bits in time. So here actually it's quite intuitive. So you have 8 bits that take 16 nanoseconds. How much will one bit take? Right? Bit rate is how long. So in 1 second, how many bits? Right? So 8 bits, 16 nanosecond, 1 second, how many nanobits? You would end up with the same thing. You end up with the same thing and the same file answer. This in this case, it was easier. They gave us all the values. Bits per second, yeah. Bits per second is the rate. Okay. So that was this question. It was fairly easy once we understood how to read this diagram. Okay, let's move on. Question 9. Okay, give me a minute. Okay, so this is the next question. This is a relatively complicated question than the others. It's not. It is simple actually. It's not very complicated, but it involves a little bit more formulas than the other. And these I think these are quite useful, at least the ones from the lesson, because maybe not the theory questions. They may not ask direct theory questions, but like these kind of questions which come from the textbook, this could be asked in an exam because at least in fact it won't be open book, so they might ask questions. But again, you have to you would know your faculties and how they set papers. But there's no harm in solving questions that are in your textbook. So which textbook is this from? Your official textbook. So official, you should know your official textbook. Eros. That's the guy who wrote the textbook. I'm just going to leave that on the slide. Okay, anyway, let's solve this. What is the total latency? What is the total latency for which is latency for a frame of size 5 million bits that is being sent on a link with 10 routers, each having a queuing time of 2 microseconds and a processing time of 1 microsecond. Length of the link is given. Length of the link is given. Speed of light inside the link is given. The link has a bandwidth of 5 Mbps. What component of total delay is dominant? Which one is negligible? So there's a lot of facts that I put in this question, but let's list all the things that is given. So we are given queuing time. So the most obvious things we're given size. So the total size of the packets, 5 million bits. Then we're given the number of routers. So what is number of routers? So you have a network. I don't know if it's visible. So you have a number of nodes. So, so you have nodes that are in a network. And so when you're talking about total delay, which is eventually going to talk about, you need to take care of every node, the total delay on the links, right? So that's why they're giving you the number. So if a queuing time is 2 microseconds, that's for one node. One node has 2 microseconds. What is queuing time? So when a packet, before it is forwarded to the next node, it's kept in a queue, 2 microseconds. It's kept in a queue. So let's say there's a packet that goes to this node, it's kept in a queue. And it's queued for how much is the queuing time? 2 microseconds. And then only that packet is sent to the next. That is queuing time. So for the total delay in a network, you'd have to have two here, two here, everywhere too. So that you'll have to multiply the number of paths. Okay, anyway, you're given routers. So let me write nodes. Nodes 10. So you have 10 nodes in the network. Next, you're given each have a queuing time of 2 microseconds. So queuing, queue, queuing time is equal to 2x 10 raised to minus 6. And this is for what? This is like we discussed before. This is only for one node. Queuing time for one node is 2 raised to 2 into 10 raised to minus 6 seconds. MVP, and again processing time of 1 microsecond. So again processing time. Again, like the queuing time, processing time is at one node. So when a node receives a packet, how much time is it processed in this node? How much time it takes to process it before it can be sent to the next one? That's processing time. Processing time you are given as 1 microsecond. So 1 microsecond. 1x 10 minus 6 seconds. Okay. Also processing time again for one node. Then we given the total length of the link, right? So length of the link tells us, so we have 5 million bits that need to be sent, and that these are almost corresponding details. So you have a frame of 5 million bits, and that frame of 5 million bits need to travel along 2,000 kilometers, right? So total, I'm going to write total length that needs to be traveled. How much? 2,000 kilometers. Or you can write as 2,000. Let's just simplify it now. So 123 meters. Okay. What are we given next? Speed of light inside the link is this. So why are they telling us the speed of light? Speed of light. They're telling us speed of light, and if you recognize 2 to the 10 raised to 8, it's the same that we had in some previous question. Yeah, propagation speed of 2 is 2. So that is that is the answer. Propagation speed. Right. So if you have a link, how fast something takes to propagate from one end to the other, that's 2 into 10 raised to 8 meters per second. So speed of light, which is so it's not really speed of light, so it's propagation time. Propagation time. Propagation speed, sorry. Speed, which is speed of light, which is in this question 2 raised to 10, 2 into 10 raised to 8 meters per second. Okay, now what are we given? The link has a bandwidth of Mbps. So bandwidth. So what is bandwidth? Bandwidth like the bit rate. So how many uh, network speed? That it's not really a term, but 5 Mbps. What that mean? 5 Mbps. So 5 Mbps in 1 second. 5 million bits get to pass through the network. Now you might think like if bandwidth is given, then why not? Why speed of light given and bandwidth given? The speed of light, it says the speed of light, but doesn't say that the network operates at the speed of light. The propagation speed that it can is this much. But the network, the bandwidth takes into consideration the capacity. We saw that also we saw in a previous question. The capacity is also taken by the bandwidth. So the total capacity per second is 5 millibits, so megabits, 5 megabits per second. And the speed of light is this much. So we will need this information as we saw. So bandwidth, I'm going to write here capacity because it's almost capacity, network capacity, network, just for us to help us solve this question. Which component of the total relay is dominant? Which one is negligible? Okay, so we are given all these things. Actually, let me go down. We're given queuing time, processing time, propagation speed. Not the time we'll need to convert it into time. Yeah, we're given the length. So how much it takes for transmitting, that also we're given. And so what will total delay be? Total delay. That is going to be the delay for all the subparts. What are the subparts? What subparts am I talking about? I'm talking about delay for queuing. So let me write delay queue or queue delay plus processing time. So there's a processing delay plus total length that needs to be traveled. So there's a so how long it takes for something to be transmitted from one place to another. So there's a transmission delay. Transmission. And we have a capacity of the network is such. Network. We have a capacity of the network of this much. So the network delay. The network delay, I think is network delay. The propagation. Propagation. Propagation delay. So it's not sub delays. That's yeah. The question, which component is dominant, which one is negligible? You have all these delays. And so they're not asking us actually to calculate the delay. They're just asked us these components. And they've only asked what is dominant, what is negligible. So all that we need to do is calculate all these delays. Calculate Q delay, processing delay, transmission delay, propagation delay. And then at least make it all the same unit. Q delay, what is it? Already it's given. This, let me just copy. Okay. Bandwidth delay, processing delay, also given directly. Delay, so processing time is that much time is going in processing. That much time is going in processing. That's a delay that is present. So for example, like this is 1 microsecond. 1 microsecond delay is there. So when a packet from one node wants to go to another node, that delay is there in processing. So that's why it's the same thing as how much time it takes in the queue. That is how much delay the queue is causing. Okay, queue delay, processing delay is fine. Now we need to find transmission delay. Transmission. What is transmission? Transmission. Transmission. So when you're transmitting, it's about how much capacity. And when you hear capacity, you should know bandwidth immediately. How much are you able to transfer in in 1 second? That's the transmission. No, sorry, that's the bandwidth. How long will it take to transmit given your bandwidth? Yeah, that's the correct way to put it. How so let me type it here. How long will it take to transmit given the bandwidth? Bandwidth. That's transmission delay. Right. Propagation. So what is the difference between this transmission and propagation? Propagation, this is the propagation. This is how much it takes, how long it takes to cover the entire network from one end to the other. So if you have 2 points, how long does it take to cover that distance? How long it takes to cover, right? Now that we have everything, now we just need to solve. So let's transmission. So transmission is something that's dependent on the band, and propagation is something that's dependent on cover. So with speed of light or speed of whatever is given in the question. One is it bandwidth and one is it light. Okay. So what is transmission? Transmission delay. How would you solve this? Delay, so how long? So again, time, again, we're having time. And time, again, you need distance by speed. So this formula will keep coming in networks. And it's a simple formula, you should already know this. What is the distance given the bandwidth? So bandwidth is how many megabits? So it's divided by 5 Mbps. So we know that. Or we can write 5 MB, so million. So that's how much. But what do we divide it by? What is the length? Length, if you given the number of bits, that will be the length. We are given the number of bits. Frame of size 5 million bits. So simple. So it's bits by bandwidth. Bandwidth. Right. So 5 million divided by 5 million. Yes, divided by 5 million. 2, 3 equal to 1. 1 watt. So you have 5 million bits. This is in bits. Transmission is also in bits. This is also in bits. So it's seconds. 1 second. Next, propagation delay. How long it takes to cover the speed of light. So you have something, and the 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 speed, the denominator, that's the speed of light. So x divided by speed of light is speed. What needs to travel at the speed of light? So what is traveling? So we saw if we have one network from to the other, how long is that? How long does it take from one node to the other? You have 2 points. How long does it take? What is the distance? How long is the distance between the two nodes? Yeah. So we are given that also. Link, length of the link, 2000 kilometers. That means you have this point and this point, the total length to kilometers. So you can write megameters. 2000, right? So, oops. Yeah. So x is going to be length, length, or in general just any length, any length of anything you choose. That will be whatever's given divided by speed of light. So length we are given 5. So 2000 kilometers. 2000 kilometers. So it's 2000 and three more zeros divided by speed of light. Speed of light was given as 2x 10 raised to 10. So 2x 10 raised to 8. Yeah, 8. So we get this very big value. So it's actually, wait, 2 raised to, mm, so wait, let me write it down. So 2 and 8 zeros, 1, 2, 3, 4. How much would this be? Yeah, that's the answer. So yeah, there was a problem with the brackets, right? So that 10 raised to 8 was supposed to be in the denominator. That's how many. So you have the kilometers, link length, divided by the speed of light. That much. That much what? Seconds. Now, what the question was asking. So after we solved all this, of course, if once you knew this, queuing time, processing time is given, you can immediately calculate transmission and propagation speed quickly. What is the question answer? What is dominant? What is negligible? You just have to see now among these, what is dominant, what is negligible. So we bring this also down. What is dominant? Dominant means what is the biggest, what has the most influence. So if you're calculating total delay, we don't need to calculate total delay, but if we did need to, you would add all these things. And you can see this is a very small value. I'm sorry, actually the fourth one is even smaller. 1 into 10 raised to minus 6. The top one is the largest. So this will have the largest delay. So if we were to calculate, let's say total delay TD, we would just add everything up. It would come to like 1.01 something something. Most of the influence is coming from transition delay, and the least influence is coming from the processing delay. That's your answer. Dominant is transmission delay. Negligible is processing. Now, if you want to look at this question and ask, like, what is what makes transmission so dominant? You can look at what transmission is. It's bits per band. If that was asked, so it's bits per bandwidth, and a large size of bits is what's causing this high transmission delay. Do we have a large size of bits? We have 5 million bits. So most of the delay that we have here is coming from this, the sheer size of the frame. And why is processing delay negligible? If that was also part of your question that you needed to solve. Why is processing delay negligible? Processing delay is linked length by speed of light. And to make this processing delay less, you need a bigger denominator, which is speed of light. The propagation delay, so we know speed of light is 2 into 10 raised to 8. So the reason why processing delay, oh, not processing. Oh, sorry. Uh, processing delay, yes. Or we could still, why is propagation delay not as dominant as transmission delay? And that answer would be because the speed of light is so fast. But actually, the most negligible is processing delay. and that we don't have a reason, right? They're just given us processing time is 1 microsecond. So due to the amount of time that due to the small amount of time that nodes takes to process, processing delay is less and therefore does not contribute much to the total delay. Hence, it is the least. It's the most negligible. So dominant delay, the yes, most dominant delay, most negligible delay. Yeah, that's the answer to this question. You could have done this a lot faster. You just needed to know that this is how you calculate transmission propagation delay. Yeah, this is how you calculate transmission propagation delay. You could have put it, you would get very easy calculation. Compare it with these two, Q delay and processing delay, which is already given in the question. And that's it. Dominant and negligible, you'll be able to answer. Yeah, that is how this question is solved. So I think we have almost come to the end of our time slot. So it was supposed to be from 8 till 8 till 10. It's 9:45. Okay. So let's just look at what we did today. Or mm, so what the plan is, we plan to do so packet switching next class. So next class will be all about switching. I don't think there's another module 3 class after that. Let me module 2 class after that. No, there isn't. So next class is going to be all about switching. All questions like this, we're going to solve some textbook questions from the Bayros textbook using that are based on switching. Like today was all like, yeah. So that's about the next session. So in this session, we did only network parameters. Mm, yeah, okay. I think everyone's muted. Okay. This question about delay and bandwidth sensitivity. You would need to know that delay and, and bandwidth sensitivity. Yeah. So if you've read your textbook, you can see delay sensitivity and bandwidth sensitivity in a table. I don't know whether you have looked at that. This question is actually from the table. If you're wondering where that this question came from, maybe I can show that, or I'll have to search for that particular table. But it's something that was there. That's part of the parameters. Yeah, we looked at this question. We looked at delay sensitivity and bandwidth sensitivity. How you can decide whether something is delay or bandwidth sensitive. What makes something delayed or bandwidth sensitive. So this was remote server. Even if it is not a remote file server, even if it was like just two nodes, the answers would most of them would be the same. Then we looked at theory questions. We looked at the word jitter. We saw attenuation and amplifiers. These are all actually part of your syllabus. Then we started with our textbook questions. We saw transmission time. We saw propagation speed and how we can use that. So what we noticed is that there's only one formula that you need to actually remember. And that formula you hopefully already know. So distance, speed by time, speed, distance by time, or time, distance by speed, or distance, speed into time, whichever way. This is all that you need. And based on that, you can calculate all sorts of things. just need to know if distance is the length, speed is a bandwidth, or in some cases, if it is propagation, what is the speed, what is the length. That's all that you need to know. Bits and bytes, this also you should. Then we saw another question, length of a bit, and we saw how big a bit can actually be. Then we saw bit rate. It was again the same thing. Length by time, but this time length was actually the number of bits, how many bits you're moving per second. Then we saw bitrate, another bitrate question, but this time they didn't give us any values. They just gave us a diagram. And from the diagram, we had to pull how many bits are there, how long it's taking, everything. And then finally, in the last question, what we saw was, so it's, you had to do multiple, you had to find multiple delays. You have multiple times you had to use the formula, uh, distance by speed, everything that you needed to use. They gave you two of the delays, and all they asked you was dominant and negligible. And all you needed to do was to compare all the delays with each other and tell which is dominant and negligible. Yeah, I think that is all for this session. It's 9:50. Yeah, I tried to do questions from the reader, from the textbook, but if any of you have other sessions, like if you think that you want to do a different textbook, you can tell me. But we have finished, so I think I can stop recording now.